Welcome to solving polynomial equations. Okay, we're going to solve most of these polynomial equations by factoring if possible, and you'll see sometimes when we need the quadratic formula. So in order to factor polynomials, a couple things to consider. First, write your polynomial as p of x equals 0. So set your polynomial equal to 0. Get all the terms on one side. That's what this statement's telling you. Factor p of x and use the zero product property. And you've seen that in the last video as well. So we're going to factor p of x and use the zero product property if possible. And you'll see in some cases where we'll need to use the quadratic formula. All right, so what are the solutions to each equation? And we only had room for one on here. So the second slide will be the second part of this problem. So we're going to solve this equation. What are the solutions? That's what it means. When you solve an equation, or what are the solutions, you want to know that you want to solve it. So we have 2x cubed minus 5x squared equals 3x. Step number one, get p of x equal to 0. So I brought the 3x over. So now we have minus 3x, and notice how we've set that equal to 0. This is a polynomial of degree 3, and we haven't learned how to factor that yet, and you'll learn in a couple of videos how to do that using rational root theorem and some other methods. So look, all the terms have at least an x, so factor out the GCF, and that GCF, the greatest common factor, is x. So I factor that out, and look inside, I have parentheses. So I factored out an x, and basically you divide each of these terms by x, and this is what's left. Now you have to see if you can factor inside, which you can, and you get the quantity 2x plus 1 and x minus 3 times x. If you're having trouble factoring this, multiply the 2 and the 3 and you get negative 6. Two numbers that multiply to be negative 6 and add to be 5 are negative 6 plus 1. So over here I've shown the steps how to do that. I didn't do that over here. Okay? So now you apply the second bullet, the zero product property. So x equals 0, x equals negative 1/2, or x equals 3. Those are my zeros of that function, or the solutions, the x-intercepts. Remember, we have a lot of ways to call that, but these are the solutions for x. Okay? Now, in part B, we have 3x to the fourth plus 12x squared equals 6x. Again, set p of x equal to 0. That's the first step, and so now you have negative 6x cubed on this side, and that's all equal to, we can put that equal to 0. Now, notice how I put the negative 6x cubed before the x squared term. I try to keep this in standard form. So again, I'm going to factor out the greatest common factor here, and notice it's 3, 6, and 12. 3 goes into all those terms, but the smallest amount of x's I have is x squared. So I factored out 3x squared, and now I'm left with x squared minus 2x plus 4. All that's set and equal to 0. So I know that x squared equals 0, so x is going to be 0. We have a multiplicity of 2 there. Or x squared minus 2x plus 4 is going to equal 0. So I got to try to factor that, which I can't. And so here you can see the steps for the quadratic formula. And you're actually going to see us have imaginary solutions there. So when I plug in a, b, and c into the quadratic formula, I'm left with 1 plus or minus I root 3. And that's after simplifying. So if you need to see that simplification, here we go. I'm not going to get too in depth. You plug in your values for a, b, and c, and you actually get negative 12 underneath. 2 plus or minus the root of negative 12 is the same thing as 2 plus or minus 2i root 3. Remember, 12 is just 2 root 3 simplified. And then each term has a divided by 2, or divisible by 2, so that's why I have the 1 plus or minus I root 3. So you have x equals 0, x equals 1 plus I root 3, or x equals 1 minus I root 3, and you found these two imaginary solutions by using the quadratic formula. And remember, x has a multiplicity of 2, but we just have to state that 0 once. And that's important because we're going to talk about that degree and its significance to the amount of zeros you can have in a polynomial later on. Some factoring techniques of review. I didn't put them all up here because we've used the GCF a lot, but I wanted to make note of the difference of two squares pattern, remember, and the sum or difference of cubes patterns here. Okay, so take a second to write these down. We know how to factor trinomials. We know what perfect square trinomials are. Factor by grouping. We've done that when we do the trinomials when a is other than 1. So you've seen all of these, but these are just different methods that you could use or you're going to see when you solve polynomial functions. All these are good different types of factoring techniques. Remember at the beginning they talked about solving polynomials by factoring because it's a little bit easier. So these are the types of factoring patterns you may see. So it's good to know all of these. Okay, I only wrote the ones in red because these are, I think, the most challenging for you guys to remember. All right, let's solve. X to the fourth minus 3x squared equals 4. This is one of my favorite problems to do because it's a little bit tricky. Okay, so again, bring the 4 over. That's step number 1. On every one of these problems when you solve, you set your polynomial equal to 0. So we got our terms over. Just 4. So here's my polynomial. Here's the problem though. Not all the terms have an x. So now it's like, well, how do I factor out an x to the fourth? Well, we got a little bit of trickery and it starts with the first term here. Well, x to the fourth is just x squared squared minus 3x squared minus 4. And here's the trick. Look, these two are x squareds. So let's substitute. Let's let a equal x squared and see what happens. So a is going to be x squared. So instead of writing x squared, we have a. X squared is a, but a to the second power is just a squared. Minus 3a minus 4. Here now, that's a quadratic function. I know how to factor that, and I can factor that into a minus 4 times the quantity a plus 1. That's equal to 0. Now we substitute our value for a in. We factored it. Now you resubstitute x squared in for a. Okay, not x, for a. All right, so that's what this last step is. Instead of writing a, we go back to x squared. So we have x squared minus 4, that quantity times x squared plus 1. So now we factored by bullet 1 on the first page. Bullet 2, use the zero product property. So x squared minus 4 equals 0. So x equals plus or minus 2. And x squared plus 1 equals 0. So x equals plus or minus I, right? Subtract the 1, and you have this x is equal to the square root of x equals plus or minus root of negative 1, which is just I. Okay, so we have 4 zeros here, and notice the power on x. The degree is 4. And again, we'll talk about that later. So this is a nice tricky problem. You'll see this a lot. So it only happens when you get that fourth term and that squared term, and you have another term with no x's in here. So you got to watch out this specific pattern right here: x to the fourth minus some number x squared minus a constant. If this is an x term, then you could factor, but then we'd have to look at how to factor a cubic. So just be careful here. So that's the big thing. We let a equal x squared, so it allows us to factor, and then you resubstitute your x squared back in to solve. So there's the first part, step 1, factoring that polynomial. Step 2, use the zero product property. Okay, and so don't forget to substitute your x squared back in and set each of those binomials equal to 0. And the last example here is difference of, it's going to be a difference of two cubes. So we have x cubed equals 1. A lot of people might say, well, that's just going to be 1 or negative 1. But again, set your polynomial equal to 0 because you're solving. And I do that, and I have x cubed minus 1 equals 0. These are both perfect cubes. So a is going to be x, and b is going to be 1. So we go ahead and substitute. And I have x minus 1 equals times the quantity x squared plus x plus 1 equals 0. Not a perfect square. So the zero product property tells me that one of my zeros is 1. Or, now here again, quadratic formula. Negative b plus or minus, right, the square root of b squared minus 4ac all over 2a. I've simplified that here to the answer, negative 1 plus or minus I root 3 over 2. And here's the work I've shown to do that. Here's the quadratic formula. Here's my opposite of b plus or minus b squared minus 4 times a times c all over 2. And then you simplify. So there's the steps here on the side. So I won't always show the work here. Okay, I put it on the side. And it's good for you to show your scratch work. So if you need to think about, how did Mr. Bennett get that? Here's the scratch work right here for you to see. I know you guys want to pause that and see. Okay, so that is solving polynomial equations. Remember, set your polynomial equal to 0 first. Factor if possible. to get, and then apply the zero product property. You won't always be able to factor. You're probably most likely going to have to use the quadratic formula. And just remember, I showed you a bunch of factoring techniques that we have used, so just be aware of those. If you have any questions or comments, type them below, or you can email me at nicholas.bennett@dc.gov, and we'll see you next time.